Welcome all you tech enthusiasts, you curious minds, and those navigating the electrifying world of bits and bytes. This is 𝐁𝐤𝐤, the podcast that promises to be your guide through this ever-evolving universe of IT and beyond. So, let's do it. Hi everyone, I'm Adrian, and today we are talking about an exciting topic of design thinking and its role in shaping AI solutions. And with me I have two exciting experts, Dr. Okulska, Inez, and Mateusz, Kaczorek. Hi guys, how are you?
I'm good, thank you. How are you?
Oh, I'm all right, thank you. Thanks for asking, actually, yes. Inez, how are you?
As good as it's possible and during the winter, you know.
Oh yeah, tell me about it. Tell me about it. I can't wait for the spring and summer, definitely. One thing worth mentioning at the beginning is you guys are two co-authors of a white paper based on design thinking and AI solutions, amongst our third colleague, Jarosław, right? And today's episode will be kind of discussing the design thinking and the concept of AI solutions. So let's maybe start by introducing ourselves, right? Telling a bit more about ourselves. So Inez, maybe you start. Tell me, who are you? Why are you here?
I keep asking me the question to myself. No, I'm not part of SoftServe, but I was really enjoying the work on this white paper and on this topic. I'm a senior research engineer at the moment at Wroclaw University of Technology. I actually used to be a leader of bigger teams developing solutions, AI solutions, mostly NLP, natural language processing. But I came originally from humanities, and it's actually, I think, an important part of my official biography, because this is why I always think about this, human-related things and human-centered design, or just, I never forget, even when I'm diving deeply into the technology and developing the models and new solutions, I never forget about the humans, and this is why we were here, and this is why we chose the topic for the white paper. So
fantastic. So two things. First of all, it's safe to say that you know what you're talking about, right?
Mostly.
Yeah, that's good. That's good. We need that. We need that for today.
Actually, I should also say I'm also editor-in-chief of the 𝐻𝐢 magazine. It's part of this campus AI district. A huge and nice initiative in Poland to focus on AI, and it's a magazine that actually also promotes the idea of human plus AI, of human, again, centered, human focused AI solutions, and spreading the knowledge about AI, but from this human related perspective. So.
Perfect, because actually this is something that we talked about before you came on, which is this white paper and the concept of kind of design thinking is a soft side of technology, right? It's a human side of it,
exactly,
which is more approachable for the mass audience as well. It's easier to understand.
It's a good way to bridge the topic, right?
Yeah. Definitely. Good. Well, I'm very happy you're here then. Thank you. Mateusz, tell us a bit more about yourself then.
Sure. So actually, I'm mostly on the technical side of this piece, and I'm currently working as a senior data scientist at SoftServe, leading the AI projects, data science, machine learning, and so on and so forth, however we call it. Mostly only actually right now in generative AI solutions. So the best picks on the market right now, I would say. So this is my main activity. Hence, this white paper also covers some our use cases that we had in SoftServe. Also, after hours, I'm exploring and researching memory for artificial intelligence.
All right.
So how to create systems that can store the memory, self-actualize, so on and so forth. So it's pretty hard and nice concept for the future.
And for personalization, right?
Yeah.
Yeah.
Definitely. Yeah. So that's
okay.
me.
Good.
And right now, also a podcast attendee, it seems. So
Perfect. That's definitely worth mentioning. And you see, this is the reason why I'm in between years too, right? Because we have a technical person and a soft kind of approach person, right? So I need to kind of split you apart.
Okay, but I hope you feel comfortable here.
Yeah, sure, perfect.
And the sandwich.
we'll connect the dots.
Exactly.
Cool.
Before we kind of move on, just one thing I want to clarify, because I'm quite biased here, because I mentioned to you before we started recording, I love AI, I love technology, so it's a pleasure to kind of talk to you and understand at deeper level what design thinking is. And I will try to kind of stay clear of being biased by maybe challenging some concepts and maybe trying to learn something from you, if that's okay.
But your being biased means you're positive, you're enthusiastic?
Positively biased.
Okay.
Positively biased, yeah. Let's get that straight. Okay, last question.
So we don't have any bad guy here, right?
No, but we will in comment section.
Okay, I can be the bad guy.
Yeah. No, there you go. Hopefully. We'll change roles. Guys, before we go into the merit of the conversation, question I ask every guest in this podcast: cats or dogs?
Ooh, hard
Neither.
one.
Turtles?
No, people.
People. Okay.
Definitely, and models. Yeah.
Nice.
I'd love to have dog.
Okay.
When I will have bigger apartment. For now,
Good.
cats.
Okay, good answer. I'm a dog person, so that's a plus
easy,
for me.
okay.
Nice. All right, so let's set the stage, guys. We are talking about the white paper. We'll link,
which is black.
Which is black. That's true. But we will put a link to it online. It's also available in printout. But let's maybe start from the beginning. So, what encouraged you and kind of pushed you to write this?
To choose a topic.
Yeah.
I was asked to lead a workshop at SoftServe.
Mm-hmm.
And I was being told that actually the majority of people attending there will be technical people. So maybe it would be clever to come with some engineering topic, but then I thought, this is exactly what they do like every day, and this could be interesting and boring in the same way at the same time. So I wanted to actually add some value to bring something different, to just some mind opener, let's say. And I used to teach at the Warsaw University of Technology some classes around the design thinking for engineers. There was like automation engineers more than AI, like strictly AI. And then it was like 2 or 3 semesters and I always observed how big of a difference it made on those, engineers to be. And then I thought, okay, it could be it. Actually, it's not as often discussed as it should be.
Yeah, okay.
Usually we have only so much time, so we actually focus on how to deliver the solution, how to be up to date with all this new emerging models and methods and everything. It's really hard to not get a FOMO when you're in this area in this field of AI. So I can imagine that it's not typical to dive into not directly related topics. Mm-hmm. So if you are going to spend some, couple of hours on your Saturday, because this event was on Saturday, then you actually should get something like really, new and something, refreshing. Yeah. And it was quite. I ran the topic by the organizers, and they were like, okay, that sounds like something that could be actually interesting for both HR people and the engineers. So something like you said, to bridge and connect between.
Yeah, definitely. Thank you. Mateusz?
It was actually very refreshing to see something not technical on very technical, in a very technical place. I'm coming from the same background as Inez said, so Warsaw University of Technology, which is a strictly technical university, right? And firstly, when I started working in data science, I had to a little bit unlearn this very technical approach and see where was the clue, like what needs to be done to make artificial intelligence or machine learning system actually work very well. And it turns out that you need this human factor, this user factor, and we tend to over focus on the technology approach. So it was a very nice idea from Inez to do this workshop, and I got a lot of information, something that was in my head before. So I saw some problems. I saw where we should look, but it was not something yet. How would you call it?
Defined.
Yeah.
The thing is, it's not that I brought anything. Everything was new to them. I mean, they were like very skilled and educated people. But I guess it was more like I just sorted some things, some thoughts together, and just made some new clusters of the data that they already had in their heads, in their thoughts. The thing is, when you think about the training of engineers, I don't think it's only a problem at our technical universities. I think it's all over the world. That usually you think about exactly solving the problem from the technical perspective, and the problem is already given to you. It's like, they have a task, you have like a book with, tasks and solutions when you have to just follow the method. And this is what you learn, how to solve a problem. But you never really think about formulating the problem, about asking why should you do this in the first place. And this is actually one very important question in the real market. And I wanted just to make this step back and just ask the question. Okay, I know all of you are brilliant engineers. You know how to solve the problems. Let's talk about the problems themselves.
Good point. And I would like to. There's a perfect quote from Elon Musk who said that. Yeah. Hard one. So.
Yeah.
But he said that the biggest trap of a really good engineer is to solve or optimize problems that shouldn't even exist. And this is something that Inez said, that it is actually true. For like 5 years of my studies, we never formulated a problem from the scratch. We didn't learn how to do it. So yeah. It's very important.
Yeah, it's generalized, right? Because it's not really fit for purpose for most cases. It's just, you have big AI models. They're not fit for all solutions, all purposes for all users, right? And design thinking is more about targeting and focusing this into a specific.
Those big models is, they are really Okay, I'm not going to finish this, the sentence, but really painful for me to watch how overused they are. Because they tend to solve every problem, they're really likely to be used or wanted by the client, right? And
tempting.
Yeah, it is tempting. I mean, I used to work with AI, I started 7 years ago, so no large language model inside, like a really good one. I mean, just GPT or GPT-2 wasn't really, with the showing this quality. So it wasn't really something your clients would like to use. So it was, I don't know, it was good times. I mean, we were really playing with some small solutions, explainable ones, and you had the chance to understand what's going on, to really, it's like a bit of, I love Lego, the blocks.
Me too.
And I used to play with that like some 30 years ago. So we can, figure out how old I am.
Last weekend.
Yeah, me too. But I have kids, so I have perfect excuse. But I used to love this, that they were so simple. They were so, so...
Elegantly simple.
Elegantly simple. And you had to think about what you want to do, and you just chose the right part, and you were creative about it, and you were creative about the interpretation. Yeah. And now you have a Friends or something, or this architecture. I mean, it looks nice, but you only get those blocks that are actually for this one.
Very specific.
Yeah, very specific for this one, creator, and that's it. Yeah. And it's sad, I think.
Yeah, it's blocking your creativity.
And it's I think it's a little bit there is some similarity between how you solve problems right now with these big models.
Yeah.
And I used to love the simple elegance of random forest or linear regression or even LSTM. I mean, it's a simpler model, but but more complex than a random forest, but still super simple compared to these large language models. So,
you mentioned, just to kind of jump in, you mentioned solving problems, but I think the problem is that you tend to not solve the problem because you're using too big of a model and you're asking the wrong thing, or the user group is
the
wrong.
The thing is, because this huge shiny thing like large language models, they're huge and shiny. It's exactly what people like. I guess it extrapolates to different fields. So the thing is, people, the clients, the decision makers, especially last year and the year before, they were like, we want to have it. Everyone has it, and we want to have it, no matter for what for, right? And it's like, I want to do some generative AI. Let's do something. What can you do? Oh, maybe this. Do you really need it? Do you really want to use it?
Should actually be the first question.
Yeah.
Like, do you actually need it?
Yeah. That's the thing, and that's the question that's never asked
what you really need.
in training. Right?
This is what we talked about as well. It's like jumping on this bandwagon of AI. Everyone's AI. Everyone wants to use the models because it's hyped. It's cool.
And we see some reports on business reports on different industry areas, and you can see, for example, 70% of small and middle businesses wants to integrate some AI, etc. And I was like, okay, they want to do it, and they declare that they want to do it, but do they also follow up the question and ask what for? And is it really needed, or you want to have it because it's the FOMO thing?
They just want to have a logo on their website. They're using AI.
It's
like
right.
they're kind of out there with all the.
If Toothbrush can have an AI, why not my company? Right? Which is more complicated than Toothbrush.
It was the same thing with Internet of Things, right? It was the same hype that every single object in your house or around you, or some wearables, that it can collect the data. And what for? Who's going to use the
dishwasher
data?
with AI. Guys, we're steering. We're steering into a direction of a different topic, but let's maybe
it's the same topic, because it's always the same thing. Because it was always with Internet of Things was exactly the same question. There were a bunch of engineers. They came up with technology, and it was really nice technology to show off on some road shows or some conferences that we as humanity are able to do so and so, but actually who needs that and what for? And there was exactly the same problem that you had, for example, light bulbs that you can use as for music, to play music.
Speakers.
Right?
Oh.
I mean, it's not. It doesn't even. It doesn't even make sense. I mean, the music coming from such a small speaker, it can be good, and you just really don't need to combine it with your light bulb. You probably already had some dedicated object that was some device.
Like gimmicks, not unnecessary gimmicks, but just showcases the ability of creating such technology, right?
And the same with generative AI. You can do everything, so you do, but what for?
Yeah, that's true.
And we always want more,
That's true.
Just a quick anecdote. One time I wanted to buy a blender. It's a simple thing, right?
No, it's not.
Well, of course, I would do research for 3 months. But then I chose, there were 2 sets. One with Ice Cube Crusher and the second one without it. I bought the one with Ice Cube Crusher just to be able to crush the ice cubes. And for 2 years, I never used it.
Yeah, exactly, right?
So that's like with the speakers,
Yeah, that's true.
So
that's true.
It's tempting.
Yeah, perfect. Mateusz, while you're talking, answer me this question, though. Okay, so going back to AI, going back to design thinking, first of all, we kind of skipped the explanation of what design thinking is, right? From technical standpoint and from soft standpoint, I guess. What is design thinking, right? Because it's a methodology, right? It's a way of approaching, building or creating models, but I'll let you guys explain. Mateusz, do you want to give it a shot?
I'll start with maybe how it can fit in in our software engiering, let's say.
But you have to say the definition first. Like, what is it? And then explain how it fits.
Essentially is starting with different questions when you're building a product, a system, a solution. And is starting from the end users and someone who would actually use the product on a daily basis. So we're trying to first assess what are the needs, what is the potential use case, how it will be used, and so on and so forth. So you're putting this person, let's say, or personas in the center of creating the process and at the start of the process, not at the end, not when you want to test it if it's built.
You flip the process.
Yeah, a little bit,
Yeah, so actually it's a methodology to develop solutions, to develop projects or products, not because it's possible and not because it makes the engineers, who came up with the idea, proud or happy
and busy,
but because it's really needed and it's really tailored to those who we think need it. So it's user and human-centered design, and this centered is like really design thinking really means that as a methodology. So you actually incorporate this user and this human from the very first question and from the beginning, and you iterate, and it's also a very important part of this methodology, that you iterate, and this iteration and slightly or sometimes boldly changing the initial idea is good. It's not something bad that you have bad guess at the beginning. It's just adjusting to your users, to your to those who really need this technology. And in this approach, the technology itself comes very late to on the table, because first we need to ask the question, what is the problem that we need to solve? Who is affected by this problem? And then we try to interview or this target group and do some market research and analysis. And based on that, there is ideation. And so creation of ideas that could be really solving this problem. And some way in this step, we can start to think about this about the technology, but we should never start with choosing the technology and then trying to find a product that will,
fits for this technology, right?
Well, this is it. And this is how I understand it, right? Because as I said, this flips the process, right? And not to undersell its importance, because I think this should be everywhere. Like this approach should be everywhere. But you also mentioned in this white paper that it's actually rarely applied these days. It's still not that common.
It's not, maybe not rarely, but it's not that common.
Not that common, because it's
I would say
it's quite
it's
logical.
It's maybe it's not nowhere. But I would say it's a little bit of an upgrade of Scrum and Agile methodologies that were tackling a little bit this problem, right? With iterations, with trying to shape the product or the system. But this one is, it tries to set the human more into the center and more into the front.
I just have a thought that actually a lot of small how to say that? Not startups, something like that.
Teams?
Like small businesses. They, especially in the field of AI in Poland, they actually get funded by this national funds. You need to apply for grant, and you get this grant. A lot of small businesses, they pair up with some scientific teams from different universities. They just, with some project teams, and they apply for grants, and they do some interesting things within those grants. But the thing is, when you write this project, when you come up with this application, you have to justify why is it new, why your methodology or why your technology you want to use is new and different, etc., etc. And this approach actually encourages this overthinking part of this technology and not really, focusing on this real problem and real needs that needs to be solved. And this is maybe part of the problem because, the whole culture of coming up with projects with ideas is just also flipped, but the wrong way.
The wrong way around, yeah. And I think this is also talking about the workflow of design thinking, which first step is empathy or empathizing with.
Yeah, this is a very, very important word in the engineering world, I guess.
Which is not very technical.
But no, it's not. It's not. And we say that it's the last thing that AI would
learn.
Be able to mimic or simulate. Because, but it would be nice if engineers could do. I mean, they're still humans.
Do you?
They're capable.
Empathize?
I'll try to.
As a person, I guess you do, but as an engineer.
No. Actually, I preparing for this podcast and before this podcast, I was actually thinking how my approach changed over the years when I'm an engineer, and it changed drastically. Okay. And I mean drastically, and especially I would say in the last 2 years, 3 years, when I started working with. Within some startup research and so on and so forth. And we had to really try to focus on the user and how they could benefit from our approach on our solution. This one. And also when all the ChatGPTs and those models came into place, businesses and people that wanted those technologies. So probably everyone right now, unfortunately, or
except for the skeptics.
Except for the skeptics. They wanted it so bad, but we saw that they have even less understanding of what it can do and what it can't do than before. So before I was working mostly with some IT leaders, technical people in some companies. They knew some parts of the technology and hired us to create some system. Right now, we're talking usually straight to the business. Business people, not IT people, not technical people. And this gap is huge. So
and you just want what other have, right?
Yeah, and you need to empathize more and get into the skin of this person to see actually what is this business about, how we can help, and so on and so forth. So there's a huge part. Yeah,
well, this is a thing. Like you actually mentioned business, and I didn't plan to, but let's talk about business because actually, you think about it, right? Let's be serious, right? Because if you think about it, design thinking approach to AI solution actually benefits business a lot because first of all, you're saving some business a lot of money for not spending on massive models that they don't need. And you're asking them the right questions. Why do you need it? Do you actually need it? Maybe you just need automation or something, right? So there is a lot of value to the business you can bring by absorbing this.
But you need to see this as an investment. Because to make it happen, you actually need more people than usual, and not just those engineers and consultants, but you need also this design thinking, trained people, so to say. People who would do the interviews, do the market research, the analytics, etc., etc. And then, you need to be able to iterate. So maybe it will take a little bit more time than intended. So in a way, it can be sold badly, so to say. But you have to see it as a long-term, huge benefit that will actually, bring you really forward and among your competition. So it's a really good one, but sometimes it's like when you need something right now, quick and in a safe way that you deliver, that you actually deliver something, and you just choose known methods. Then it's like, it's too painful.
Do you know this saying, you need to spend money to make money, right? Exactly. So in this case, this is you need to spend money to save money. Like it's kind of different kind of variation of it, but it kind of is true, right? Yes, if you need something ASAP right now, I need some AI model to help me with this and that.
Yeah, maybe to save money and make money too, because if you have like really tailor-made, nice solution that solves an actual problem, it will. The word will be spread.
Fit for purpose as well, right? They will do what it was designed designed to do.
Yeah,
and nothing less, nothing more. It's there to deliver you the value, and this is the whole point. That's why I think personally, I'm surprised this is not everywhere. Like as in within IT models, I know there's those general big models, sure, right? But in essence, this is the common sense of how you should approach building those kind of solutions. Sorry, you wanted to say something.
Yeah, about the saving money. Actually, the right research on your target group, on your personas, could also show you that they don't want like 7 different functionalities. They just need one. So you don't need to spend time and money and effort on doing something that will be never used, like the crushing ice thing. So that's one part of it, but the problem is you have to deal with, I guess, the other group that have something to say. So the marketing people who say, okay, how am I going to market something that just does one thing or something like that? I mean, it's not impossible, but it's not that common. And we are in we live in the times where we want everything to be big and capable and having like 1,000 different
functionalities which you don't need.
Yeah, exactly. It's just you need to be really
big and shiny. It's beginning to be in the companies a little bit of political stuff, because they want to gather some resources, some money to create some project, right? And then you need to sell it. You need to sell it to your stakeholders, which will be business people. And it's easier to sell a rocket that will go to the moon or even Mars than to sell a car and average.
Yeah, that's true.
So it's sometimes it's super hard, and we had such cases that we needed to downscale the expectations quite a lot. It worked well, but it was not an easy task.
But also coming up with these ideas. I mean, it's much easier to just have some CEO or with IT people together with engineers in a room. They just sit together, they talk over coffee, and then they say, oh, it would be so cool to have a system that does that and that. Oh yeah, this sounds really cool, and they just keep convincing each other it's a really good idea, and everyone buys it, and it's cool. Let's do it. And in a way, there are a lot of ideas that are really easy to sell when you talk about it to your decision makers.
Yeah.
And they, in this kind of ideation, you don't need time and you don't need money to actually, analyze the market, find the people, find their problems, deep dive into the problem, and it's just easier. It's quicker. It's more shiny. So it's much easier to come up with something. And not, justify it and see if it's really
it's how you position it, how you market it as well, and again.
But on the upside, it's once you find a real problem and you say, okay, I found a group of, disabled people, for example, in a very, special, rare problem. And I interview them and I see, and here are the statistics, 80% of them have this and that problem, and we can solve it by doing this and that. And it's actually market share of, real users. That could actually also be very easy to understand for decision makers. And they're like, okay, that sounds like you found your clients, so that's good. But you have to do this first step, and it's just some effort at the very beginning.
Sure, agreed, perfect.
So that's your answer. Why it's not everywhere?
If it was that simple. Definitely. So guys, let's maybe talk about discrimination in AI models. I like to kind of touch on this, and maybe it's kind of a vague term here, but let's talk about biases, right? And in this white paper, you actually bring up quite a few very interesting examples of applications, right? And one which is maybe closer to my, I don't know, maybe not heart, but brain, I guess. From experience speaking recruitment-wise, there's an example here you mentioned about a company in APAC who implemented a model that was ageist or racist. I don't remember, because it was discriminating applications based on age, for example, right? Which is just a terrible thing, right? And this was without the design thinking approach. And I guess this is how, or maybe answer me this question, how design thinking influences this bias in AI.
The thing is, you need to think about the use case scenarios. The problem that's going to solve is one thing, but then the other very important thing is the production, so to say, the real world your solution is going to live in. So how it's going to be used and by whom and for what for. And if you build a recruitment solution, it's usually an easy problem to solve. You want to find the best candidate. There are, of course, a lot of questions to be asked, like what does it mean to find the best candidates? If the best candidates for your company means, I don't know, the best educated or with best range of soft skills, etc., etc. So it's first thing to ask what type of people do you need, or what type of matches do you need actually? And then you will seek the data that actually have those and those features annotated in this data set. And this is first thing. If you want to serve all humankind, so to say, so male and female and maybe other genders, then you actually need to have this data set evenly split between this, be representative, evenly split between those classes. And I actually use this example saying male and female and other genders, because it's also one thing when you could say, okay, we want to not discriminate women, for example, by collecting data that is biased. But it could be possible that your client says explicitly, but we also want to be inclusive and we want to be open for, 20 other gender types or something like that. And it's okay. I mean, they need it. But it's really important then to find the data to just make sure that it is really represented in your database. Because if you want to include it and you don't have it in your training set, your model will not know it what your client wants. And here the problem was the data was biased. So it's also very important to know your data. And if you know that you don't want to bias data set, you have to think about every aspect of it that could show the features that you want to hide or just want to omit to not make it biased. So that is the problem. That if you think about all the scenarios, if you think about your data, if you understand and know your data, you have to just consider every possible thing that could go wrong. That is also that is also one very important thing in design thinking. You don't only think about what's going to be perfect and what's going to be successful in this product. You have to think about all the possible bad scenarios and just try to counteract.
Yeah, but that's it. Like, sorry, Mateusz, you want to add something?
I wanted to add a very important thing that about bias, because machine learning models and AI models are actually trained to catch bias. This is actually a task to do, and because of that, they can predict something better than we do, because they can see in the data what features, what parts of the data steered the model into which direction. So let's say we have a credit risk, right? And you're going to a bank and want to have a loan, right? But it turns out that in the previous data, people with a similar credit score than you had a very long time when they paid for the money that they borrowed.
Yeah.
So machine learning models are actually good and best in catching something like this, and it's not a bad thing actually, because
it's auditing itself.
It could be, exactly. So when you had a bad history of credit, it seems like it's not a bias that you didn't get a loan, right? It could be a case of actually this case, right? So, but the important thing is to exclude the features like this, like gender or age, that could wrongfully bias our data. That is one. And to set some guardrails, right? What could be fair or what shouldn't.
Yeah, and the thing is, even if you have the best staff and you know, in your company, you have to put them for the right job. And this is it's exactly the same thing with AI. As you said, the models are capable of finding those bias, but you have to you know, make them do so. You have to, you know, incorporate. Yeah, you actually not even train. You have to just incorporate the step into your process. And this is what we were talking on writing about in this paper, and we call it internal explainability. And it was the next step after you had this idea, the first prototype. You asked all those important questions, did the market and research and personas and everything, and then ideated the solution, prototyped it, and then there's this very important step of again taking a step back and looking what you've done, and if it's any good, and it means this internal explainability. For example, to looking again at the data set, looking at the right metrics, looking very deeply, for example, which features are most important, what the model, based on what the model learned,
decided.
The predictions, because usually the models are lazy. And they're just trying to find the most distinctive features. And if you slip, if you just overlook something which is very obvious to the model, like, for example, this women's something name and some, I don't know, hobbies section, it will be enough for the model to know for sure that it's a woman and it should be put somewhere else than the man. And that's what's creating the bias.
Yeah, exactly.
Yeah, so it's really important to, before we come to this explainability that helps the users, is external explainability, just, you know, the interface and explaining to the users how the model works, etc. It's really, really important. I guess it's actually my favorite part, besides the empathy, because it's very human related. But this one, like from the technical view, it's my favorite part, just to explain to the engineers, explain the models for themselves, just to see if they should iterate and just, you know, remove the bias. Or not only bias, sometimes it's just they should optimize the model for different metrics, because actually it was, I don't know, sometimes...
Too lazy.
Too lazy, yeah. Sometimes you can have, like, you know, a very high accuracy. That was the example I was showing at the workshop, that a model can have like 99% accuracy and still be useless. Yeah. Like completely useless.
Yes. I believe you even mentioned in this paper there's so much abundance of data, but only a very low percentage of it is actually useful, right? Because of that's also the problem, right? But it's again with this Internet of Things. So we are able to collect the data, so we collect the data, but then we are not able to do anything helpful with the data. Just, you know, come up with, because when you have like flood of data, you also have to have the idea what to do with it, how to analyze it, from which point of view. And it's exactly the same thing, actually. This, even for data science, you need to actually design thinking, right? To ask the right question. What am I going to find in this data? What I'm looking for?
Yeah, but this is more convoluted problem, because not always you can apply those things. Let's say that like a lot of technology, especially like in AI or before, like in physics and so on, like they created this technology. They didn't know it will be used in 50 years doing some magic stuff, right? And we cannot, you know, implement and design everything in this way, or something that you said about the grants. If you're following some scientific research, it is also like incredibly hard to predict, even in 1 year or 2 years, where this technology can be used. Not to mention like 50 years or 30 years, right?
Yeah. But this is a different thing. I mean, science should be innovative, that's sure.
Yeah.
And you should just push the boundaries and look for new solutions, etc. But this is on the scientific level, where you don't wrap it up in a product. Right?
Okay, yeah,
when you do a product, then you have to think about its users. When you do science, you're just, you know, doing science.
Totally right.
Yeah,
that's true. That's true. Okay, guys. So last thing I wanted to mention about real world examples, which relates to healthcare, because it really is close to my heart. It really is, and I really want to kind of explore, this field, right? Mentioned in the white paper.
Mm-hmm. You want to start with the example, and I wrap up the problems.
There you go.
We were talking a little bit about bias and some unfair bias sometimes, or poorly designed systems, poorly explained, as you mentioned. And there was one of the probably most famous stupid, quite frankly, examples in healthcare when the algorithm was trained on examples that had some bias in the data set, but super simple, that whenever there was a potential or high probability of cancer in patients' lungs, it would have a ruler next to the lung during a scan. The problem was that in the final image, the ruler was placed there and was visible, and the model pretty lazily tried to, or just learned to predict whenever there is a ruler, there is a cancer. So pretty straightforward, and even maybe made sense. But in the real scenario, there was no ruler. There was just the image of lungs, right?
Yeah.
And this is a typical problem in healthcare. Actually, there are I guess at least 3 categories of problems that have to be thought through when you want to follow this design thinking methodology. The first thing is actually the data. What kind of data do you need? And in healthcare, it's super important to think about this, not only the scenarios of use case scenarios of the end model and solution, but also about the annotation scenarios. So who's going to annotate the data and where the data is coming from? And there are a lot of examples where there are different devices, for example, from different providers. And there was also another example of this lazy model that overfits. It's called overfitting, when the model just learns wrong feature. That it's just makes it easy to predict, but it's not the really most important, best describing feature of what we were looking for in the data. And there was this problem that there was it was about the iris. So very much connected to our design of the white paper. The thing was that healthy people were delivering the data, so to say. They were, but they have been examined with some other device, because it was in different place by different technician than those ill people, sick people, and the clinic, because the clinic had just there are only two types of this kind of device providers, but they were different, and the model just learned that this image coming from one device means you're healthy, and coming from the other device means you're sick, which is not true, because you can come to the clinic and let you be examined and just still be healthy. Well, and this is one problem. So you have to think about this annotation, and sometimes it's about the device, and sometimes it's about the people, because there are still a lot of people actually annotating the data. Annotating, which means they put just the labels to make it possible for the model to distinguish between different types and classes of data. And you need to think about your annotators. It cannot always be the first people you meet and agree to do this. And sometimes it's you don't think in your budget about the data. It's just, okay, let's take something because it's available, or let's take our, juniors because they are available. And you have to think, it's fine, but you have to think, it's not, maybe there are only women doing it, or only men, or only people in their 20s, or only people who, know this topic or language or something. And and it's not that there's only one recipe to put together your annotator stuff, but it's really important to think about it if they reflect your problem. So again, you have to think about this users' use case scenarios, about your target group, about the problem you're solving, and think, what kind of data do you need? And this typical problem of visual models discriminating colored people was exactly this kind of problem, that in the data there was like white people labeling white faces, and they just didn't think about expanding the data set. And then once you have other users coming and just won't see them, and so this is really important. And the other thing in the healthcare is also thinking about the metrics. So how you optimize your model, what you're actually looking for, what's best. It's not possible to have it all. So you have to, find, there's always a trade-off. If you want, especially if you have some diagnostic model that tells you if you're sick or not, it's really important to ask your users, your patients, the question: is it better to have a model that it's that it gives you more false positive or false negatives? Which means, do you want your illness to be overlooked?
Yeah.
Or do you want to hear bad news even if you're healthy?
And of course,
misdiagnosed. And usually people say, okay, I want to know the truth. I want to, every time I'm sick, I want to know the truth. And it's, it's obvious to say, but then think about the other case when somebody tells you you're dying and you're just gonna, live for another month or something. And what are you gonna do with your life? Knowing this, and then after the months, oh no, sorry, it was a model error because we just optimized for recall, and it was just saying everyone that it's sick. So this is really important question. It's not just engineering thing that we just use some hyperparameters when doing the models. So it's a really use case scenario, because in some cases, it was the same example with COVID, right? If we wanted to have every case catched early, or we wanted to lock down like a lot of people even if they were healthy.
It becomes philosophical and ethical
problem, right? But also very important for the economy, right?
Yeah, of course.
So many institutions were closed, etc., etc. So it's not just it is something that you learned when you were trained as an AI engineer, but it's actually a huge problem that needs to be discussed and asked before you actually use it. And this is what we are also stressing here in the paper, is that the responsibility when doing this technology is far wider than you think that it is. It's not just doing something that works, but it's also that, something that works for somebody.
Definitely no. Specifically when you talk about healthcare, yes, ethics, huge, role to play in it, but repercussions, and responsibility behind certain decisions made by a machine. Yeah,
this is why we need to explain and iterate and see what's happening, right?
Yeah. And you know what? One of my first questions, I don't know if I asked this question, but the first question I wanted to ask you at the very beginning was, what challenges, design thinking in collaboration with AI can bring. But we kind of answered this in a very kind of long manner. But now, when I asked this question at the very end of our podcast, it makes sense, because we showed, you showed, what kind of benefits this approach, this methodology can bring. Right. And yes, I'm a huge fan of AI. So I hope this will develop into something real, something tangible that can actually safely add value, especially in healthcare. So fingers crossed. But one, maybe, unless you want to add something else, but one last question I want to ask is about future, because again, it's always something that kind of interests me. What can we expect? Any trends in this concept of design thinking? Will it be more common than it is now, or not?
I would say it would be. I have two different ideas in mind. So one is, as I said, I think design thinking is kind of an upgrade of those Swift methodologies like Agile and so on. Yeah. And it probably will blend into this as a form of evolution. But the second one is very, very interesting, because I saw some nice research and papers about using generative systems like GPT and so on to create personas and fake users, and to streamline this process. Because why design thinking is not in every possible project? mainly because we don't usually have access to users all the time. It is hard to implement actually in reality. But here we can kind of supplement those first iterations with some generated personas and start from it, right? And then include the normal users.
Okay, can I be the bad guy?
You're talking about implementing AI into AI.
Yeah, exactly. It's exactly the future. I mean, our agents helping other agents. So, I think it's obvious that it's going to be the future. But I totally agree with you that it's that the fact that you can use AI to make it easier at the beginning, to make more. To go deeper, to do the research, to do the empathy part, etc. It's very important. It's very helpful, and it's actually there's much hope for design thinking because of that. But then you have to think design thinkingly when doing this, which means if you wanna do your personas of very small underrepresented culture, don't use this very global, slightly biased into West cultures model, because the personas could be also not like truly represented, etc., etc. So
there are no shortcuts. That was not what I.
Yes,
what I wanted to say.
I'd say human plus AI, right? So we have to have somebody that will overlook that and who will steer that in the right way. But it will save a lot of time and money, and I guess it makes it easier to convince your decision makers to wait a bit and make it better and just implement the design thinking iterations. And so the outlook is positive.
Okay. Yeah. Okay, good.
Sounds good.
Will we be out of jobs soon because of it? I'd like to know in advance. All right.
No. I mean,
humans are needed.
Humans are always needed. Yeah. I mean, we especially know the limitations of AI, right? And I think there will be more specialized models, which means they will not be omni models, like in a really omni way. And you always need people asking right questions and fact-checking them and challenging and doing so many things.
It's a long way. Yeah. It's a long way. It's hard for me to, at this point, visualize a place where we wouldn't have human in the loop at some point. It is super hard. Even if we try, we really try, but it doesn't work. No, most of the time.
I mean, cheap leaders will try to
try, but
replace.
It at some point it fails and it backlashes even. So
I mean, the market will just show them.
I mean, pretty rough way, but
exactly.
Could be actually.
That's true. But we
were talking about empathy. Empathy is superhuman, and I believe in superhumans, which means humans and empowered by AI and working together arm in arm. So
people forget, very existential right now, but people forget that with every advancement, every technological advancement, comes this skepticism, comes this fear of losing jobs, losing purpose as human beings, right? And it was the same with with cars when they were introduced instead of horses and all that, and all the technological advancements. People forget that we persevere and we advance ourselves. So my personal, and I think quite common kind of viewpoint of this is that, yes, some people will be replaced by AI, but we will evolve into different roles. We will have different roles. So we will kind of shape into what's fit for purpose. We will not disappear, right? And this is the main point. So to all the skeptics, out there,
and
don't worry.
More problems will emerge. And which means there will be more true and really existing problems to be solved, and not and the best engineers don't have to come up with problems that don't exist. They can start to solve those really well.
Yeah, absolutely. And actually, on the last episode I was talking about AI as well with R&D guys from SoftServe as well, and they actually said something quite interesting as well, because developers are afraid of losing jobs, junior developers, because they think, AI, I mean, come on, right now I'm not a developer. I can go into ChatGPT and ask them to write me a simple code, right? And junior developers are afraid to lose jobs.
Will you put your money on that?
That's a different question.
I wouldn't.
and I wouldn't either. But the problem is, or not the problem, the solution is that, yes, Chat can write you a code, but the more valuable employee will be the junior developer who knows how to use AI.
Yeah.
Yeah, they were just
that's the whole
advancing
thing.
more quickly to be intermediate or even senior, and that's the best part of it.
Did you watch it? You just quoted the podcast. You had to watch it.
But actually, it gives you more hands.
Yes.
And I see it from my perspective. I'm mostly in this data science AI stuff, but if I want to do something simple in a different area, right, like in containerization or something else, right now I can do simple stuff with just learning some stuff from ChatGPT or some other copilots. So it just makes my job easier. And also, this another developer, I don't need to prompt him for some simple thing. I can do it myself.
Exactly.
So it gives me
I'm a scientist,
one more
so
hammer.
I love it that I also have HDHD, and this is a very important factor here because once I have a hypothesis or some idea, I need to check it very quickly. And together with ChatGPT or Claude, I can just write a lot of code just to very quickly see if my thoughts are, steering the right direction or
is feasible and so on, right?
Yeah, if I should, go the other way around or just do this. It's really satisfying to see that it's, almost as fast as my thinking.
We're making ourselves more capable, I would say.
That's exactly
and we're
it.
raising the bar also, I would say.
Yes, so use it to enhance what you do, not to replace you. I think this is the main thing, right? Is learn how to use it, how this can help you. Yeah. Perfect. Anything else to add on design thinking? Let's use it.
Never forget your users. I mean, every technology is for somebody, and there is somebody you need to ask if he or she really needs that, and what for, and how you can make it better.
I think it's always good to first, when you try to solve some problem, ask why, and if you really want to solve it.
Yeah, it's more like how can I help, and not look what I've done.
Exactly.
Exactly.
And actually, the title of this white paper is actually perfect.
Yeah,
right?
it's the perfect summary of
who, how, and why.
Yeah,
right? It's exactly what design thinking is about. In association with the right data sets, of course, but this encompasses everything there is. Right? So
and how is not first, right?
Yes,
how
exactly.
Actually, the typical definition of design thinking would have like 4 W's, and it'd be who, what. Oh, actually, what, who, how, and why.
And why?
Yeah, because it's like what is the problem, who's affected, how to solve it, and why is it important. So
perfect.
Cool.
And with that, I thank you both for participating. Really pleasure to speaking to you. Design thinking will stay with me for a long time.
And with you,
hopefully.
And with our listeners, of course, or watchers. I hope to see you again, because again, this topic is so vast and not just about this white paper, but we could talk about it for a long time. So as kind of the last words to say is to our audience is definitely worth reading. It's not long, but it's so compact and it has a lot of value. Again, from non-technical standpoint, it's definitely worth a read. So guys, thank you, and Jaroslav as well for writing it. Definitely appreciate it. And to our audience, stay curious.
Yeah, thank you.
Thank you.
Cheers.